Class, welcome to Piecewise functions. Okay, we are moving on from transformations, which we will still absolutely need during this section, but we are going to introduce this concept of piecewise functions today. So, piecewise functions, basically what we're saying here about piecewise functions are, well, they are pieces, okay? They are multiple functions. I'm going to put in parentheses pieces. Okay, multiple functions or pieces combined together to create one function. Okay, now there's a couple of things here that are important. If I'm creating one function still, we know that functions have to pass the vertical line test. Okay, so that means that I can take as many pieces as I want, but they have to pass the vertical line test, which means that there cannot be any overlap. Alright, there cannot be any overlap. So for example, if I take some parabola, let's move up a little bit to the top, okay? If I take some parabola, maybe like this, and I draw like that, well, what would happen if I also take a line, something like this? Alright, that's a problem. I can't do this. Why? Because there is overlap. This does not pass the vertical line test. What we would have to do in something like this is maybe my parabola would come to about here and stop. And then right here, maybe I can start a new line or something like that. Now what do we say? Pass the vertical line test? Sure, even here, right? It doesn't hit here, but it hits here, and we're good to go. Okay, so this is kind of what we're looking for. This is good. This is bad. Alright? Alright, now before we jump into some examples of how we can use the piecewise functions, I do want to just let you know we've done stuff like this before, okay? And hopefully this will be another good example of what piecewise is. Like, do you remember back in Algebra 1, or maybe even before Algebra 1, I could give you a word problem. Like, how about something like this? Mr. Rabins is walking to school, and he suddenly stops because he needs to check his backpack for his lunch. So he stops and he looks around for a little bit for his lunch, and he realizes that he doesn't have it, so he has to walk home. As soon as he walks home and gets his lunch, he realizes that he is he is very late to school, so he has to run to get caught back up and go to school and make it on time. Okay? So what did I do here? Let's change colors here. I broke this up, okay? I had 4 different sections of a graph, right? This would have been the first part of my walk. This would have been when I was stopping and looking for my lunch. This is when I walked home, and this is when I ran to school. This is a piecewise. These are different functions broken up and kind of put together to create one single function. Okay? So now, today what we're really going to do, we're going to kind of see, we're not going to do as much graphing today, okay? We're going to see how these piecewise functions work and hopefully have you guys start to feel a little bit more comfortable with these concepts before we jump right into graphing. So, here's a good example of a piecewise. This is what it'll look like. It'll have a function notation, and then it'll usually have a squiggly bracket with any number of functions that create it. Now, this is the important part. I have to give you very specific domain restrictions on each section. What do we see here? Well, if x is going to be less than 1, well, then it takes this shape, or this function. And then if x is greater than 1, it takes this shape, or this function. Alright? So that is really, really important, 1, when you're graphing, but even 2, when we try to find some of these values, find the outputs. For example, if I want to find f of negative 2, well, we have to realize negative 2 is what? Greater than or equal to 1 or less than 1? Yeah, less than 1. So I have to plug f of negative 2 into my top function. If I plugged it in here, it wouldn't get me anything, right? This is not part of my piecewise function when x is negative 2. All right, so we plug in, we have negative 2 plus 1. That should equal, that's a positive 2, so 3. Okay, we can keep going. Negative 1 is positive 1 plus 1 is 2. Right? If I plug in negative 1, it becomes positive 1 plus 1 is 2. And if I plug in 0, 0 plus 1 is 1. So notice that for these three, x is less than 1, which means I have to use the top piece of my function. What happens when I move on to the next little part here in letter D? If we notice, letter D is find f of 1. Well, so now f of 1, is that less than 1? Or is it greater than or equal to 1? It's equal to 1, so yes, it's going to take the second function, or the second piece. So 1 squared plus 2 equals 3. And now I know all of these other ones are also going to be greater than 1, so I know I'm just going to take the second function as well. So 2 squared plus 2 equals 6, or 3 squared plus 2 equals, what is that, 11? 11. All right, so kind of similarly, I said that all of these three were less than 1. Well, all of these are greater than or equal to 1, so they have to take the, they have to take the second piece. Okay? Now, we know some things here. What shape is the graph for the numbers that are greater than or equal to 1? Well, greater than or equal to 1 looked like it had a square function in it, and square functions are going to create parabolas. And we know that our first function, or our top function, for when it's less than 1, was linear, right? There's no exponent. So this is linear, which means it will be a line. Now, here is the deal. We are going to try and graph one of these, okay? We're going to try and graph one of these. So let's bring our notes up a little bit. And here's the important thing. One thing that I would always suggest doing is marking your boundaries, okay? I know that right at 1, there's a switch occurring. So I'm going to kind of dash that in just so I know, and I can think, I know things are going to change between the left and right side of this function. My suggestion is always to find boundary points. And what do I mean by that? Well, I know that this top function is going to go all the way up to x is equal to 1, but it's not going to include that point, right? So I'm going to put an open circle at x equals 1 for this function. So if I plug in 1 here, negative 1 is negative 1, plus 1 is 0. All right, so I have a point at 1 comma 0, but remember, because it cannot equal 1, it's not less than or equal to 1, I have to put an open circle there. All right, and actually, you know what, guys? I'm going to stay consistent. I'm going to change that to a blue. I want to change this to blue because that was my blue color. Okay, now, for my second function, the boundary point, I know it's also going to occur at 1. So when I can plug in 1 again, 1 squared plus 2, yep, it's still 3. Now this time, am I using an open or a closed? I can close this circle, and the reason is because it's allowed to equal 1. All right, this is the important part about saying there's no overlap. If I do the vertical line test right here, this still passes because it technically doesn't hit at 1 here, but it does there. Now, for the rest of this, there's a couple of different options. One thing you can absolutely do, you can always take points, right? I know f of negative 1 is 2. I know f of negative 2 is 3. I can plot those. All right, that tells me what this is going to look like over there on the left side. One other thing I want you to just be aware of, especially when you have lines, linear equations, you know the slope, guys. The slope is negative 1. Okay, the slope is negative 1, so you know that on the left side you have to have a slope of negative 1, which means you can go back 1, up 1, back 1, up 1, back 1, up 1. Okay? So that's one important idea. For parabolas, it's a little different. I'd almost say that the points are easier, but a little more time consuming. Like I now know that I have a point at 2 comma 6 and another one at 3 comma 11, something like that. Okay, so I know what this is going to look like. The other thing, we just got finished working on graphing parabolas. Okay, so one thing you can always do is if you know that you're graphing x squared plus 2, you can use your growth pattern, right? I know that for a parabola, it's a 1, 1, 1, 1, 1, 3, 5, 7. Notice I'm changing into pencil here. I hope it shows up, but it's because I'm going to want to erase this in a little bit. Okay, I have my growth pattern. There's no vertical stretches there's no vertical stretches or shrinks. There's no horizontal stretches or shrinks. In fact, there is only a vertical shift up 2, which means I'm going to put my vertex here, and then I'm going to go over 1, up 1. Hey, over 1, up 3. That's funny. Over 1, up 5. Oh, I went a little too high there. Let me change that. Okay. I could go back the other way, right? And then kind of sketch. Here's what I want you to remember, though. Okay? What do I care about? Well, that's really hard to see. Let me go darken it a little bit. What do I care about? You have to remember this is piecewise. There cannot be overlap. This function only starts at x is positive 1 and then goes wherever x is greater than 1, which means you need to get rid of everything else. Okay, so you would have to get rid of that line. Does that make sense? Hopefully. And now I would just kind of sketch in with green so I know for sure that that is my piecewise function. Okay? Okay. Let's move on. Let's see what's going on here. And then we will call it a day. Alright, so let's try a piecewise with 3 pieces. 3 pieces. What do we see here? We know that where x is less than or equal to negative 2, it will take on x minus 3, the equation x minus 3. From negative 2 until 2, not including, it will take on negative x squared plus 5. And then lastly, x is greater than or equal to 2, it will take on x minus 4. So, things I would probably want to think about here is what I'm going to plug in where. My green is going all the way until is less than or equal to negative 2. So that's going to be right there. Once I'm on the other side of it, it's going to take on this middle function. Okay. Now, one thing to be very careful about here is it says it's not including negative 2, right? That's why I'm not going to include the negative 2. It's just going to start at the negative 1. And actually, it's going to be the same thing here. So I'll go maybe there to there, there to there. And then lastly, my x minus 4 will be like that. With that in mind, I think we can now find some points. Well, x minus 3, when we plug in negative 4 minus 3 is negative 7. And when we plug in negative 3 minus 3 is negative 6. And negative 2 minus 3 is negative 5. Okay, because these values are part of the first equation's domain, you have to use the first equation. Now, the next set is taking the middle domain, the negative 2 to 2. So I have to plug in these values into my middle or second piece. Well, negative 1 squared is 1. Negative 1 plus 5 is positive 4. 0 squared is 0. Negative 0 is just still 0. 0 plus 5 is 5. And then lastly, 1 squared is 1. Negative 1 plus 5 is 4 again. And lastly, x minus 4. So again, these 3 values right here come from my third domain or my third equation, my third function. So 2 minus 4 is negative 2. 3 minus 4 is negative 1. And lastly, 4 minus 4 is 0. Okay? To finish up, what I want us to do, I just want us to get comfortable with this idea of breaking the graph kind of in half or into how many ever pieces there needs to be, and then kind of writing what it's going to look like. We're not going to get into the actual graphing yet. But what I do again care about is finding the boundary. So we notice here when we look at our function, we have two pieces, and that boundary seems to be right at -3. So what am I going to do? I'm going to split my coordinate plane, and then I'm going to notice that when x is less than -3, okay, the domain is less than -3, I use the first equation, or the first piece. Well, this is a square function, so this is going to be a parabola. Alright, and how about this second piece? What do we see? No exponent, or an exponent of 1, so this will be a line. Alright, last one before we finish up. Okay, I have 3 pieces now, so I'm actually going to have 2 boundaries, it looks like. I'm going to have a boundary at -2, so I make that boundary. And I have another boundary, it looks like at 3, so I'm going to make this boundary. Alright, now we just have to do some investigating. The leftmost, or the first piece, where x is less than -2, looks to be linear, so this will be a line. And our next piece, and actually let me underline that, underline this one. Okay, our next piece has a square in it, so this is a square function, so this will be a parabola. And our last piece, ooh, I see a cube in there. Okay, so this will be cubic. Alright. So again, hopefully you guys are understanding the concepts of the boundaries and really being able to understand that I have to kind of think about the domain of each piece, right? Like I know that if x is less than -2, it's going to take this piece, the line. If it's between -2 and 3, it's going to take my second piece, or the parabola. And then if x is greater than or 3, it's going to take this cubic function. Alright, so that's a good introduction to Piecewise. We will jump more into it and really get into graphing later. Have a good day.